Let's jump right into today's explainer. We're looking at Mise, pronounced mice, which is a seriously impressive AI-native inventory management MVP developed by student engineers at UMGC. And right off the bat, I want to say this isn't some fluffy marketing concept. We're unpacking a highly professional, well-architected technical foundation that is genuinely designed to fix how commercial kitchens manage their stock. So here's our roadmap for the explainer. 1. Introducing the Mise team. 2. Tackling kitchen food waste. 3. Platform features and a quick demo. 4. AI and technical architecture. And 5. Lessons learned building Mise.
Okay, Section 1. Introducing the Mise team, the engineers behind the MVP. This CMSC 495 team designed Mise to be a whole lot more than just a glorified spreadsheet. Dan Nunes steered the ship as project manager, supported by Robert Lee as assistant project manager, and Adan Medina guiding the requirements as product owner. On the engineering side, we've got Spencer Renfro leading the front end, Arth Tucker heading up the AI and cloud architecture, and JJ Escondor running the back end. The team also wanted to give a huge shout out to Professor Castillo for his incredible support throughout this capstone project. Together, this crew really laid down a rock-solid foundation.
Moving right along to Section 2, tackling kitchen food waste, which is the core problem here.
The harsh reality of the restaurant industry is that ingredients constantly expire before they ever make it to a plate. Why? Because kitchen managers usually lack real-time, trustworthy visibility into what they actually have in the walk-in. Without a single source of truth, kitchens end up over-ordering and menu decisions are essentially just made in the dark. Restaurants are literally bleeding real money because of this blind spot every single day. Mise exists to completely fix that. It acts as an early warning system, alerting kitchens about at-risk ingredients long before those expiration dates hit.
All right, Section 3, platform features and demo. Let's take a look inside. After a manager securely signs in using Firebase authentication, they land right here on the dashboard. Right away, you get these live, server-computed KPI cards. You can instantly see your total items, what's currently sitting below par level, what's expiring soon, and, this is absolutely crucial, the actual monetary value tied up in that at-risk stock. The beauty of this design is that no one has to run around with a clipboard manually flagging these issues. The system computes it all live, directly from the core data. Now, this page really highlights the team's core engineering philosophy. Everything has to be backed by server-computed trustworthy numbers. When a manager jumps over to the inventory page to add, edit, or filter their ingredients, every single row reflects that exact same data state we just saw on the dashboard. There is zero disconnect between the different views. The front end never has to guess or recompute the business logic, which is just fantastic design. And here is where the real magic happens. The menu builder lets managers generate or accept brand new menu items that are specifically designed to use up those expiring ingredients. The system passes the at-risk inventory data to an AI model, which then fires back a suggested dish. We're talking a full dish name, the required ingredients, and a logical, business-focused explanation of why it makes sense to run as a special. If it looks good, the manager can accept it right onto the menu, and boom, food waste is instantly mitigated. Wrapping up our demo loop, we have the reports page. This gives the business that high-level, long-term operational picture. You can track your waste risk summaries and supplier spending over time. It basically rolls everything up into these clean categories, so managers aren't just putting out daily fires, they can actually step back and see the big trends. It perfectly completes the entire workflow. You track your inventory, you get warned about risks, the AI gives you a solution, and then you review the long-term data. Which brings us to Section 4. AI and technical architecture. Let's look at exactly how all of this works under the hood. From a hosting perspective, the whole application runs on AWS EC2. And I love this, all their major technical choices were formally documented using architectural decision records, or ADRs. For the AI features, the team was super smart. They deliberately kept the system provider agnostic. Currently, they are utilizing a direct Anthropic API model, not AWS Bedrock, to generate those menu insights. But here's the absolute genius part. They strictly decoupled this AI path from the critical operations by building a deterministic rule-based fallback first. That means if the Anthropic API goes down or is unreachable for any reason, the system automatically pulls a suggestion from a pre-saved menu. The user flow literally never breaks. Finally, Section 5, Lessons Learned Building Mise. This is an incredibly honest retrospective from the team. Let's break down what worked and what didn't. On the positive side, creating a shared versioned contracts package was a huge win. It kept the front end and back end totally in sync, which basically eliminated those annoying integration bugs you get from mismatched data. Plus, decoupling the AI, like we just talked about, allow them to iterate on those features independently. However, it wasn't perfectly smooth sailing. They noted that their GitHub Actions CI/CD deployment pipeline actually became a bit of a bottleneck late in the game. They also ran into some onboarding friction with GitHub Packages tokens for new contributors, and late sign-offs on product pricing rules ended up delaying a few features. But, recognizing and owning these operational bottlenecks, that is the exact hallmark of a mature, professional engineering team.
So, what's the big takeaway here? Mise is a deeply grounded, impressive foundation by the UMGC team. They didn't just cobble together a flashy, fragile demo, they built a resilient, honest MVP with massive room for future improvement. It really leaves us wondering just how much these smart architectural decisions, especially that brilliant deterministic fallback pattern, could scale across the fast-paced hospitality industry. How resilient and waste-free could our commercial kitchens actually become? It's definitely something to think about.